Good morning, friends. So last class we were seeing relation, function and binary operation part 4. Today we will start more on this chapter. Okay, so today we will see the binary operation. Binary operation is very easy. Okay, let's see. Binary, what do we mean by this? Bi means mono, di, bi, tri, tetra, penta. Bi means two, right? Bi means two. So any operation in which we have two operands, then that is called the binary operation. For example, suppose we are saying 2 plus 3 equals to 5. Okay, then here this plus sign is a binary operator, and this 2 and 3 are operands. So this plus is connected to 2 only, hence we say this plus as binary operation. Similarly, we can say 2 into 5 equals to 10. Here multiplication is also the binary operation here. Why? Because here 2, 5 are two operands and this multiplication is one operator, that is giving us the result 10. These all are binary operators. So we can say plus, minus, multiplication, division are binary operators. Okay, now see, suppose what we are doing, we are defining star operation on three numbers star ABC such that this is giving us the result A plus 2B plus 3C. Suppose I am saying. Then here if we see this star operation is relating three operands, hence here this is not binary operation, this is tertiary operation. For example, here what is the value of star 235? That we will get 2 plus 2 into 3 plus 3 into 5. That will give us 2 plus 6 plus 15, that is 23. Right? So here star is not binary operation. Why? Because it is relating 3, right? 1, 2, 3 operands it has. Okay. Let's see more on it. Now see, suppose the question is the star operation is a binary operation. Star is binary operator such that it gives A star B equals to A square plus B cube. Okay, then find the first 2 star 1, second minus 1 star minus 2. We have to find these two values. Now see, star here is binary operation. Why? Because it is taking only two values A and B. How it is taking? That it will give us the summation of square of first and the cube of second. So here we will get it 2 cube plus 1 cube, that is 8 plus 1, that is 9, right? Here we will get minus 1 whole cube plus whole square plus minus 2 whole cube. That is how it is defined, right? So here we can write minus 1 whole square is 1 plus minus 8, that is minus 7. This is how we define the binary operation, right? Let's see the next. Now we have some rules in binary operation. Let's see that. The first is commutative rule. First is commutative rule. What is it says? Suppose star is a binary operation on all the real numbers. Okay? If it satisfies A star B equals to B star A, then it follows commutative rule. Okay, it follows the commutative rule. For example, suppose we are taking addition operation on the set of real numbers. Then obviously A plus B equals to B plus A, right? Hence we can say this addition follows commutative rule. Okay, addition follows commutative rule. Other example, we can take multiplication. Now A into B, we will get B into A. Hence multiplication also follows the commutative rule. Let's see, this is following. Now see, negative subtraction on the real numbers. Now do we have A minus B equals to B minus A? Not at all. For example, 2 minus 3 equals to minus 1 and 3 minus 2 equals to 1. These two are not equal. Hence, the subtraction does not follow the commutative rule, right? Now see, some questions based on this commutative rule. Suppose the question is saying there is a star operation defined on the set of real numbers such that A star B is defined as A plus 2B. Check if it follows commutative rule. Let's see. Here I am taking one example. Suppose I am taking A equals to 2 and B equals to 3. Then 2 star 3, what we will get? We will get here C first. 2 plus 2 into 3, that is 2 plus 6, that is 8, right? Now you find 3 star 2. If I am changing the order here, this also will change. So here now first number is 3 and the second number is 2. So A equals to 3, 3 plus 2 into 2, that is 3 plus 4, that is 7. Obviously A star B not equals to B star A, hence star operator here does not follow commutative rule, right? That does not follow commutative rule. Okay, that is our commutative rule. Now let's see the next, that is associative rule. The second is associative rule. See what it says. Suppose star is a binary operation defined on the set of real numbers. If it follows A star B star C equals to A star B star C, then we say it follows, binary operation here follows the associative rule. Okay, let's see for example. Let's take addition on the set of real numbers. So a plus b plus c, we can easily write it as a plus b plus c. Hence, the addition follows the associative rule, right? Let's say in case of division, subtraction, a minus b minus c. Okay? And here we will take a minus b minus c. This will be equals to a minus b plus c, and here we will get here a minus b minus c. Obviously these two are not equal. Hence the subtraction does not follow the associative rule. Okay? Let's see one example based on it. Suppose the question is saying, check whether this binary operation is following associative rule or not, where a star b we are defining as a plus b plus ab. Let's check. Now see, a star b we can write a plus b plus ab. B star a we can write as b plus a plus ba, right? Now a plus b can be written as a plus b, and ba is equals to ab. So here we are getting, and from here we can calculate here a star b now, associative rule. So we have to find now a star b star c, right? Now find a star b star c. So how can we write it? A star b, that is this all, a plus b plus ab star c, right? Now see, in the first a, replace a by this all. Okay, replacing a by this all, we will get a plus b plus ab plus second number plus multiplication of these two, c into a plus b plus ab. That is, we are getting a star b star c, right? Now see, now let's find a star b star c. What we will get? A star b star c. What we will get from here? We will get b plus c plus bc, right? Now a star this all, replace your b by this all factor. What we will get? A plus b plus c plus bc plus multiplication of these two, a into b plus c plus bc, right? Now see, these two are coming equal. Let's compare. So if you expand this, you will get a plus b plus abc, ab plus c plus ca plus bc plus abc, right? And if you expand this, you will get a plus b plus c plus abc plus ab plus ac plus abc. Obviously these two are not equal, hence this will not follow the associative rule. Fine, that is how we can check. Here we have twice, here we have a plus b plus c, here we have bc, here we have ab. That's why these two will not be equal. Let's see, a plus b plus c, we have here a plus b plus c, ab plus bc plus ca, ab plus bc plus ca plus abc, right? If you rearrange it, this will become equal, right? Hence this follows the associative rule, right? Why it is following the associative rule? Because these two are coming equal, right? Yes or no? This we have shown in general, right? If it is true for in general, right? So it will be true for any kind of particular values also, right? That is how we define this associative rule. Let's see next. Now we have identity element. We will represent it by E. See, we define the identity element. We define the identity element with respect to a, suppose star is a binary operator, okay, is a binary operator such that A star E equals to E star A, okay. Then for all A belongs to the real numbers on which the star is defined, then E is called identity element, okay. For example, with respect to addition, 0 is identity element. Okay, let's see how. Why? Because A plus 0 equals to A equals to 0 plus A, right? So with respect to addition, 0 is the identity element. Similarly, with respect to multiplication, 1 is identity element. Why? Because A into 1 equals to A equals to 1 into A, okay. Now see, other example, with respect to subtraction, suppose E is identity element, okay. Now see, A minus E equals to E minus A. Is it ever true? If you solve from here to here, you will get E equals to 0. If you solve from here here, put E equals to 0, you will get A equals to minus A, which is not possible. Hence, identity element does not exist with respect to subtraction. Similarly, identity element does not exist with respect to division also. Okay? Let's see the next. Now see, suppose star is a binary operation on the all real numbers such that A star B equals to A plus B plus AB. Find identity element if it exists. Okay, let's see. Just we have to do A star A equals to E star A, okay. Now see, A star E put here, applied here, so we will get A plus E equals to from here we will get E plus A plus EA. Now these two will be always equal, right? Now if you will solve this and this, we will get A plus E plus AE equals to A and A will get cancelled, E we will take common, 1 plus A equals to 0, so E will be equals to 0. So if E equals to 0, then this condition will be fulfilled. Hence, with respect to star operation here, E is our identity element. Okay? Let's see the next. Now how to find inverse with respect to a binary operator star. Suppose identity element exists for star operation, okay, such that a star that is a star e equals to e star a, okay, then B is called inverse of A with respect to star operation if A star B equals to B star A equals to E, okay. If A star B equals to B star A equals to E, then we say A as the inverse of B or vice versa, and vice versa, okay. Now see one question. Let's see one example. For example, with respect to multiplication, find inverse of 5, okay. Now see, and here we represent B equals to A inverse, okay. Now see, suppose let B be the inverse, or so we will get 5 star A inverse equals to what is identity element with respect to multiplication? 1, that is A inverse star 5, okay. Now here if you see, these two are always equal, right, because this is the multiplication, so the inverse of 5 will be 1 by 5, right. Similarly, let's see one more question. With respect to addition operation, find 10 inverse, okay. See, with respect to addition, we have seen 0 is the identity element, so we can write 10 plus 10 inverse should be equals to 0. So what is the inverse of 10? That is minus 10, right. That is how we find the inverse with respect to any identity element, okay. Let's see the next question. Suppose the question is saying star is defined on the set of real numbers such that A star B is being defined as 2AB, okay. Find 5 inverse. Suppose this is the question. We have to find the inverse of 5. It means here identity element should exist. First we need to find the identity element, then only we can find the inverse of any number with respect to star operation. Let's see. Suppose E is identity element, okay. Then what we can write? We can write A star E equals to E star A. Just put it here, we will get 2AE equals to, here we will get A equals to E star A, that is 2EA. Now these two will be always equal because A equals to EA. Now solving these two equations, 2AE equals to A, what the value of E? We will get AA cancel, E we will get half. So what is the identity element with respect to star operation here? Half, right? Now let's see how to find the inverse. Here the identity element exists, hence the inverse will also exist, right? Now we can write, we have to find 5 inverse, right? 5 star 5 inverse should be equals to identity element, that is equals to 5 inverse star 5, right? Now put it here, we will get 2 into 5 inverse equals to half, this is identity element, and that should be equals to 2 into 5 inverse equals to 5. These two are always equal because 2ab equals to 2ba. Now we have to solve only these two equations. Using these two equations, we can write the inverse of 5 as 1 by 2 into 2 into 5. So what is the inverse of 5 is coming 1 by 20. So with respect to star operation here, the inverse of 5 we will get 1 by 20, right? That is the inverse with respect to star operation. So this completes the whole relation function and binary operation. Okay, and hope you enjoyed this class. Next class will start a new chapter. Okay, thank you.